Hello friends, welcome back to my channel Learn India 24/7. In the last video, we have discussed and understood the below topics. Example of one sample Z test. What can change the current result of one sample Z test and Z test in Excel? In this video, let's discuss and understand below topics. Basics of t-test, difference between t and z test, degrees of freedom and t-distribution, summary of t-test, example of one sample t-test. So let's begin. In the case of t-test, the standard deviation of population is not known. This is quite common in practical life. For example, if you are testing if a new fuel additive makes your car more fuel efficient, will you be able to find the standard deviation of the fuel efficiency? This test is also known as student's t-test, not because it is used by student, but because it was developed in 1900 under the pseudonym of student. So friends, let's understand the difference between t-test and z-test. The z-test finds if the average of two data sets are different from each other when standard deviation is given. Whereas t-test finds how the average of two data sets differs from each other when standard deviation is not given. In case of z-test, the population standard deviation or variance is given or known. In case of t-test, the population standard deviation or variance is not known. In case of z-test, the sample size is large enough, that is greater than 30. Whereas in case of t-test, the sample size is small, that is less than 30. Z-test relies on the assumption that distribution of sample mean is normal, whereas t-test is based on student's t-distribution. So friends, let's understand about degrees of freedom in t-distribution. T-test uses different distribution for different sample sizes, a metric known as degrees of freedom. T-test distribution changes its shape to account the uncertainty in standard deviation. Let's assume you are given with 10 data points and you are interested to find standard deviation of those 10 data points. With those 10 data points, how do you know the sample standard deviation would match with the population? Let's say you draw randomly two samples of size 5 and 10 respectively from 10 data points ranging from values 1 to 10. The true population standard deviation in this case is the standard deviation of the values 1 to 10, which is 2.872. 1000 random samples of size each 5 and 10 were drawn from the population of data 1 to 10 and a histogram was plotted. From the histogram, in both the cases, there were times when the data overestimated and underestimated the population standard deviation. However, the sample with 10 data points had a higher probability of being closer to the true population standard deviation. The t-test accounts for this variance in measured standard deviation by changing the shape of the curve depending on sample size. The less data that you have, the more probability is put towards the tails of the curve in t-distribution. With increasing degrees of freedom, the t-distribution matches with the normal distribution at approximately 30 degrees of freedom. There is a large change in distribution while going from degrees of freedom 2 to 5 and from 5 to 30. However, there is only little change in the probability distribution while going from degrees of freedom 30 to 100. So friends, let's summarize the t-test now. The t-test uses the sample data to determine the standard deviation of the population as opposed to being provided. Because of uncertainty in the standard deviation, the t-distribution puts more probability at the tails of the probability distribution. With sufficient data points, the t-distribution exactly matches to that of standard normal distribution. So friends, let's further understand about one sample t-test with this example. The average height of female college students in United States is 5.5 feet. And you have been given the sample heights data for 15 students, and you want to determine if the average height at your college is statistically different than average height across United States. So in this case, we know the population mean as 5.5 feet, but not the population standard deviation. We will have to derive the population standard deviation from the given data. The process steps to execute one sample t-test are as below. First, determine what test to use. Then find the test statistics. Then determine if we need 1 tell or 2 tell p-value. Then find the p-value from the table and compare it with our desired confidence level. In this case, the sample set has only 15 measurements and we have only one sample. So the best test we use is one sample t-test. We have exactly one set of data and we don't have before and after data sets. We do have a population mean to calculate the difference and we do not have a population standard deviation. Hence, the conclusion is to use one sample t-test. The t-test statistic is calculated as shown below, where x bar is sample mean, mu0 is population mean, and S is sample standard deviation. Finally, N is sample size. This equation could also be rewritten with square root of n pulled out of denominator. And this equation is not really different from the z-test equation, except we use a sample standard deviation instead of population standard deviation. So friends, in this example, we have x bar sample mean as 5.673. Mu0 population mean is 5.5 as given in the problem statement. Yes, sample standard deviation is 0.3105 and n, which is sample size, is 15. When we key in the above values in the t-test statistic equation, the equation becomes as, and t-test statistic value comes to be 2.16. Since this is an example of t-test, we need to use the t-table instead of z-table. To use t-table, we need to calculate degrees of freedom. Degrees of freedom is calculated as sample size minus 1. We need to decide whether we are just looking for any change in result or we are looking for change in a certain direction. Since the problem just asks if the results are statistically different, we will use two-tailed t-test. Moreover, since problem has not specified how confident we are, by default we will use 95% confidence interval. With 14 degrees of freedom and t-value of 2.16, we will look into the t-table. The value of 2.16 is not available in t-table, but the value of 2.14 is close in. we can see that the two-time confidence at this t-value is 0.05, which means that we are 95% confident that this college has statistically different height than the average. The Excel generated p-value using the formula is 0.084, which is slightly more precise than the 0.05 value. With this, we conclude the one sample t-test. So friends, with this we have come to an end of this video. If you have liked this video, do subscribe to my channel and don't forget to press the bell icon to get further updates from my channel. Finally, thanks for watching and bye.